Hello and welcome everybody. Today we will be talking about triangle inequalities in geometry. So this entire chapter has been dedicated so far on inequalities with triangles. So now we're going to go ahead and look at some theorems that might be of interest to you when it comes to triangles and also with the sides and also the angles. So here we go. Let's go ahead and start this off. So as we said, we're going to be looking at triangle inequalities. So here in this picture, you'll notice that I drew two triangles right below this. And it's no coincidence that if you look at the largest side of any of these two triangles right here, on the left is acute and on the right is obtuse, that the opposite angle to the largest side will always yield the largest angle. So you can see that measurement of angle A is going to be the largest in that triangle ABC, which is opposite of the largest side. Whereas for the other triangle, DEF, the largest side, which is DF, will yield the largest angle, which is opposite of it, which is angle E. So that is to say, the largest side will then yield the largest angle on the opposite side. And similarly, the smallest side will then yield the smallest angle on the opposite of that side then. So that right there is going to be our theorem then, which is known as Theorem 7.5. And oddly enough, it doesn't actually have a name, but it's very important. So let's go ahead and write that up. So here it says that in triangle ABC, if CB is greater than CA, then the opposite angle of CB, which is measurement of angle A, is greater than the measurement of angle B, which is going to be the opposite of CA then. All right, so here on the right-hand side, again, you can see the picture. And we're now going to go ahead and look at the proof of this. Now, for simplicity's sake, let's do the following here. Let me go ahead and change angle A into the measurement. We're just going to go ahead and call it 1 right here. Whereas B right here is going to be called the measurement of 2 right here. So basically going back to what is it that I need to prove right here is that the measurement of angle 1 has to be greater than the measurement of angle 2. Now, the reason why I did that, calling it angle 1 and angle 2 is, well, we're going to have to make this triangle and we're going to have to take this triangle and extend some parts. So in that way, if I call it angle 1, it's actually a lot easier than calling it angle like CAB, for example. All right, so here is the first part, which is not so obvious. So that's why I have to, put this in there. I'm going to go ahead and take CA, the ray, and extend it to some point D such that CD is equal to CB. So numerically, or actually geometrically, here's what's happening. CB is going to be the largest side. So what I'm going to do is I'm going to go ahead and extend CA to some point D. So then that way its length is going to be the same as CB then. So here, let me go ahead and change that, okay? So in this picture, we're going to go ahead and take this CA and extend it and extend it and extend it to some length all the way out here to some point D. So then that way CD is then congruent to CB. And there you go. Notice now that I've created two triangles, we've created more angles. And hence, you can see why I would actually want to call it measurement of angle 1 and measurement of angle 2. Let's go ahead and throw in some more angles in there just to kind of, stir the pot a little bit. Let me go ahead and introduce angle D right here. We'll go ahead and call it the measurement of angle 3. And then this guy right here, the measurement of ABD, which I'll go ahead and call the measurement of angle 4. Now, keep in mind, my focus is still try to show that the measurement of angle 1 is greater than the measurement of angle 2. But I need 3 and 4 as kind of like the quote-unquote middlemen in order to prove that. Well, let's take this thing that we just created. CD is congruent to CB, or CD is equal to CB. We can say the following then. By the isosceles triangle theorem, I can say that the measurement of angle 3 is equal to the measurement of angle 2 plus the measurement of angle 4. Because then that means that this angle should be congruent to this angle because the opposite sides are equal to each other. So hopefully that part is okay. Now, let's go ahead and do the following then. By the parts theorem, okay, we can say that the measurement of angle 3 is going to be greater than the measurement of angle 4 because all of these are supposed to be positive numbers or non-negative numbers. So then if I take away one component, that smaller component should be smaller than the resulting component. Okay, so this is the by parts theorem. Okay, so this is something that we learned a while back, but this is basically kind of like the first time we actually used it, or maybe the second time. Well, you can see how I got the angle, let's see, angle 2 and angle 3 involved. Oh, actually, you know what? I just realized the parts theorem, I don't actually want to say angle 4 because I actually want to say angle 2 because angle 4 is kind of like a middleman that I don't really want to deal with. Okay, so measurement of angle 3 is greater than the measurement of angle 2. Still the same reason, but we just go ahead and eliminate the 4 that we don't need. Now let's see if we can relate measurement of angle 1 and the measurement of angle 3. You'll notice, hopefully, that measurement of angle 1 is an exterior angle when it comes to the triangle DAB. So we can say then by the following. By the exterior angle theorem, then the measurement of angle 1 is greater than the measurement of angle 3. Okay, now I think we can actually put it all together. If you look at all the stuff that I have, if 1 is greater than 3 and 3 is greater than 2, then by transitive property, then I can say that 1 is greater than 2 then. So here, that is going to be my final part right here. So by the transitive property, okay, we can conclude that the measurement of angle 1 is greater than the measurement of angle 3, which is greater than the measurement of angle 2. We'll cut the middleman, so now we'll just go ahead and have the largest, which is greater than the smallest. And there you go. That's going to be our proof. Can we use it to show the other angles true? Yes, you definitely can. You can just go ahead and extend AB, right? If you want to look at angle C and do exactly the same proof. But, you know, since the proof is exactly the same, we're just going to go ahead and do it once and say, hey, we're pretty much done that. Okay. All right, so there it is. Now that we showed that if you have the largest side, then the opposite angle to it is going to be the largest angle in the triangle. Well, let's go ahead and maybe work backward from that. If you have the largest triangle, if you have the largest angle in the triangle, then that means that the opposite should then be the largest side, okay? So that is going to be our next one, the converse of it, Theorem 7.6. In triangle ABC, okay, what I like to do is prove that if your angle, if one of the angle is larger than the other angle, then the side that is opposite of the largest angle is going to be greater than the side that is opposite to the smaller angle. So there it is, right there in the triangle. All right, the proof of the converse of Theorem 7.5 is going to be a little bit different. The way we're going to prove this is by trichotomy. If you remember, trichotomy basically says that if you have two real numbers, the result is that either they are equal to each other, the first one is greater than the second, or the first one is less than the second. So it's one of those three categories. So over here, then what I'm saying is that by trichotomy, there are only three possible cases that we can choose from. Looking at the conclusion, we can say that it's either CB is equal to CA, CB is greater than CA, which is what we're trying to prove, or CB is less than CA. So most likely what's going to happen is we're going to have to show by kind of like pigeonholing that the middle one is the only one that is actually going to work. Well, let's go through each case just to see how that actually works out then, okay? So let's look at case one. CB is equal to CA. Well, if CB is equal to CA, let me just go ahead and draw the picture of that. So I'm going to go ahead and redraw the triangle down here. Here's C, here's A, and then here's B. CB, which is this guy right here, is going to be equal to CA, which is this guy right here. So then the conclusion is that according to the isosceles triangle theorem, we have the measurement of angle A is equal to the measurement of angle B. And that right there cannot work because, remember, as part of the given, we said that A is greater than B. So this one is going to be kind of like an indirect proof in a way because we show that it's impossible. All right, well, let's go ahead and move on to the second one over here. Now, let's see what happens if CB is greater than CA. So here's C, here's A, and then here's B once again. CB being the larger side, CA being the smaller side. So then that means that this is going to be the larger angle, and this one's going to be the smaller angle. So by Theorem 7.5, then we have the measurement of angle A, right, is greater than the measurement of angle B. So yeah, that exactly is okay. So, you know, nothing is contradicted here. So I like that idea. All right, so it looks like case 2 looks like it's working. Case 1 is going to be crossed out. And now let's look at case 3. What happens if CB is less than CA? Well, once again, we're going to go ahead and draw that triangle, right? Here's A, here's B, and then here's C. Largest side is going to be CB. Actually, I messed up right here. The largest side in this case, the larger side, I should say, is going to be CA, which is L right here. And then the smaller side is going to be CB, so I'm going to go ahead and put S right here. Well, according to, once again, by Theorem 7.5, then I can say that the measurement of angle B is going to be greater than the measurement of angle A, because here you have L, which corresponds to the largest angle. Here you have S, which corresponds to the smaller angle. And this right here, again, does not work because it contradicts the given. So out of the three scenarios, you can see that two of them contradicts what's given, and the only one that doesn't is going to be case 2. So there it is. That's going to be our valid proof then. Okay, so now let's go ahead and see what we can do with this, because, we want to be able to apply this so then that way it's relevant. So here in this example, this is not really kind of like a geometry proof, but rather something that can be useful, that will be actually useful when you go into, like, say, pre-calculus or trig. What I want to do is, in this triangle, I want to identify the order of which each angle is by their measurement. So in this case right here, the triangle DEF, I want to know which one's the largest angle, which one's the largest, smallest angle, and which one's the medium angle. Okay, so I want to just kind of like order them by numerical measurements. Well, what we can do is apply that theorem then to what we have over here. According to this picture, we can say that DE is definitely going to be the largest side at 7, is going to be greater than DF, which is the length of 6, which is then greater than the length of EF, which is the smallest side. Now, remember, the theorem basically says the largest side yield the largest angle on the opposite, and then the smallest will yield the smallest on the opposite angle. So here's how I see it. 7 on the opposite of it, angle F, that is going to be the largest side, which I'm going to go ahead and denote as L. On the angle that is opposite of 6 right here, that I'm going to go ahead and call it M, because it's, M for medium. And then finally, for the angle that is opposite of 5, well, I guess that's going to be denoted as S, because that's going to be the smallest. So in conclusion, by Theorem 7.5, we can say that the largest, which is going to be the measurement of angle F, is greater than the measurement of angle E, which comes second, and then finally the measurement of angle D, which comes last, because that's the opposite side of 5. Okay. All right, now let's go ahead and do a proof using the Theorem 7.5 instead of Theorem 7.6. It says here we're given that DB is greater than DC. We have that B is in between A and C. And what I would like to do is prove that the measurement of angle A is greater than the measurement of angle C. So here on the right-hand side, you can see that I kind of denoted some of these right here. Again, I'll write it as L and S for, larger and smaller. Okay. Now, looking at some of the players that we have right here, I do believe that we're going to have to deal with angle C, because that is going to be the opposite of L. I'm going to also have to deal with angle DBC right here, because that's the opposite of S. And I like to do something with angle A over here. So that's going to be this guy right here. Let's go ahead and give them numerical name for the measurements, just to, again, make our lives a little bit easier. Let's go ahead and call this angle 1. Let's go ahead and call this angle 2. Let's go ahead and call this angle 3. So according to my proof, right? According to my proof, I basically need to show that the measurement of angle 1 is going to be greater than the measurement of angle 3. Okay? All right. So let's see how all this plays out. Well, the first part I notice is I want to apply Theorem 7.5. So then that means I'm looking at triangle DBC. By Theorem 7.5, we can go ahead and say that the measurement of angle 3 is going to be greater than the measurement of angle 2, right? Because, again, the opposite angle to the opposite side, if one's the largest, then the other one's going to be the largest then, okay? Now, remember, angle 2 right here is kind of like the middleman, which I don't want. So I need to somehow compare angle 2 with angle 1, okay? I want to compare angle 2 with angle 1 at this point. Looking at the position of angle 2, looking at the position of angle 1, I notice that 1 is an exterior angle. So then we can say now, by the exterior angle theorem, we can say that the exterior angle, which is the measurement of angle 2, is greater than the measurement of angle 1, which is the interior angle? Well, I think we are going to be done then, because if you look at our inequalities, right, everything is matching up. We have, by transitive property, we can say the following. The measurement of angle 3 is greater than the measurement of angle 2, which is greater than the measurement of angle 1. So once again, we cut the middle, guys. So the measurement of angle 3 is greater than the measurement of angle 1 then, okay? So measurement of angle 1, all right? So let's see here. Is that going to be it? Yes, I do think so. Wait, actually, hold on. Something is kind of strange here. Measurement of angle 1 is supposed to be greater than the measurement of angle 2. Or actually, wow. I think I might have written down the proof wrong. Okay, so I might have written down the proof wrong. So that was actually kind of my fault. Let's just check, just make sure. Measurement of angle 3 is greater than measurement of angle 2. Measurement of angle 2 is greater than the measurement of angle 1. So yes, my original setup, I think I'm pretty sure I was supposed to say that measurement of angle A is less than the measurement of angle C. So that is my apologies for that one. So hopefully that didn't screw up too much. All right, well, thank you so much for watching. Sorry about the last part. I hope everything else was okay for you guys. All right, thank you so much again, and I'll talk to you later. Goodbye.